force from potential energy next. So we saw earlier that the work done by conservative forces is equal change in kinetic energy. So we had work equals, or let's say change in kinetic energy equals work, and we said that the work was equal to minus the change in potential energy. Recall that for constant force, work is equal to force times distance delta x. Okay, so we can say that F delta x is equal to minus delta u, where F is therefore equal to negative delta u over delta x. We can convert this into a derivative, so we can take the limit by saying that F is equal to the limit of delta x minus delta u over delta x. So this can be written as du dx. So we can say that the force is equal to minus du dx. So if we know the potential, we can always find the force. Let's apply this to the spring, for example, where we are saying that the potential energy stored in the spring is equal to half k x squared. So let's say that the spring force F spring is therefore equal to minus d dx of half k x squared. So this can be written as minus, and then take the derivative, is going to be equal to minus kx. Okay, just like what we always had. So the spring force is equal to minus kx. Let's try an example. Okay, any answers for F? Okay, so just take F equals minus du dx, and u is equal to x cubed over 2 minus x squared over 3. So you just take the derivative. Okay. So if you like, we can do this. It's going to be minus d dx, and then we have x cubed over 2 minus x squared over 3. So this can be written as 3x squared over 2 3x squared over 2 minus 2x over 3. And then if you put the negative in, questions on that? Okay, let's do one more example on work. Okay, number 1, what is the magnitude of the force and the magnitude of the displacement? For force, are you giving me force? Okay. .6 meters. 3.6. Oh, 3.6. Okay. Okay, that's fine. 3.6 or 3.332, you said. What about force?
5.39.
Is that what everybody gets? Okay. So you can find the magnitude delta R by taking the square root of delta x squared plus delta y squared. So you just take the square root of so for the displacement is 2I hat plus 3j hat, 4 plus 9 13. Okay, good. And then for magnitude of F, it's the same thing, square root of fx squared plus fy squared. So what was it? It's going to be 5I squared, or 5 squared plus 2 squared, square root of 29, and that's 5.39 newtons. Okay. And then what is the work done on the particle? So number 2, what is the work done?
19.38.
Okay. 19.38 or 19.4 is fine. So for work, you're going to do F dot delta R. So you're going to take F. What is F? F is 5 plus 2. So 5I plus 2J dotted with 2I plus 3J. So it's going to be 5 times 2I hat plus it's going to be 2 times 3 J hat, like that. And then the other ones are perpendicular, so they go away. So it's going to be 10 plus 6. So what's the difference? How come 19? Did you do the same thing?
For this, I used the result for that, the previous question.
You just multiplied it?
Yes.
Oh no, that's not correct.
That one is okay.
That's not the way to do it. You have to do F dot R. F dot delta R. So you multiply it through. So you know the relationship here. I dot J, J dot I. These are 0, 0. This is 1. J dot J is equal to 1, right? So if you are, so I left the cross multiplying out because those will be 0. So this is the work done is 16 joules. Okay, that's different from just multiplying the two magnitudes together. So number 3, what is the angle between F and delta R? So part 3, we have 15.2. Let me cross this out first before we go on. So let me just correct that. The work is 16. Okay. So we have angle 15.2. So what you can do for this one is to know that F dot delta R is equal to F times delta R cosine theta. So you calculate cosine theta equals F dot delta R divided by F delta R. Okay, where the two F and delta R are magnitudes and the vectors of course are on top. So the angle theta is the cosine inverse of F dot delta R divided by F times delta R. So you can say this is equal to cosine inverse F dot delta R, we know is the work done, that's 16, divided by F times delta R, the magnitude is going to be what you did earlier, which is 5.39 times 3.6. So theta is going to be cosine inverse of 16 divided by that, so 19.4. Therefore, theta is equal to what? So what is theta on that? Is that what you did? Okay. So let's remove this one. So somebody can calculate and tell me 19.4.
34.4.
Okay, so 34.4 degrees. Okay.
We're not supposed to use arctan?
Not in this case, no. The arctan, that's a totally different thing altogether. This is dot product is a projection of A, of one vector outward. Remember how I showed you the projection of A onto B?
Yeah.
That's different from what we did with the arctan. The arctan gives you that angle, but we don't have the perpendicular.
Okay.
The tangent is the opposite over the adjacent.
Yeah.
Yeah, we don't have this perpendicular component.
Okay.
Because the dot product, the perpendicular component of the dot product is 0.
Oh, yeah.
Yeah. What? Yeah, we use cosine for this one.